Hey Precalc, it's me again, Miss Hoffbauer, and I am ready to teach you about graphing quadratics, or should I say review with you. I know you've all graphed parabolas before in other classes, so let's get to it. I hope everybody's doing okay. So a quadratic equation, would help if I had my pen ready, is anything that could be rewritten or written in this form. So it's got a squared in it somewhere, okay? And no higher power than a squared, meaning a no cube or anything. So all quadratic equations graph in the shape of a parabola. Okay, so this is the shape over here. So all of them are really just transformations of y equals x squared. The term we're going to use eventually a lot is parent function. So this is the parent function. They are all transformations of this. In other words, they've all been shifted, stretched, flipped from this basic graph. So just to get the hang of this, if we put in -2, -1, 0, 1, and 2, and we squared them, we'd get a +4, a +1, 0 squared is 0, a 1, and a 4. So they would all become positive. When we graphed them, we'd go left 2, up 4, and so on, and we'd get this shape, okay? That is the parent parabola. So anything we do from there on out, stretching, making it skinnier, wider, okay? That is a vertical stretch or compression. Shifting it left or right, reflecting it upside down. All right. Please, please, please notice that the y value here, or from the, I should start at the origin, I guess, from 0, 1 goes up 1, but then it goes up 3 more, so it goes up a total of 4 here. So please notice it does not have a constant rate of change. So when we put like a 2 out front, it doesn't mean you start here and go up 2 over 1, up 2 over 1, up 2 over 1. That would be a line, okay? So there's no slope going on here. I just need to be real clear about that because I always get students who do that. Okay. Oops. Erasing, silencing my phone. That's a good start so far to this lesson. Okay. Moving on. So what we just talked about was called general form, okay? To get the quadratic, to find the vertex from general form, we're going to use this, which I call the vertex finder recipe. So it's h equals -b over 2a, or we call it, for the axis of symmetry, the equation will be x equals h, or x equals -b over 2a. So it's all how you want to write it, but it's the opposite of b over the quantity 2a. Now, when we get it into vertex form, then we will have the vertex as h and k, and notice it is the opposite of this, okay? So if this was -4, plain old +4 would be the h, plus k. If this was -7, then -7 would be the k. And a, it's important to note, a in this form and this form are the same, and they both affect the vertical stretch or compression. All right, so let's start with standard form. This form looks pretty, not super helpful. The only thing that maybe is real easy to identify in this form is the y-intercept. Okay, so remember, let me write this down. I left room for this purpose. The x-intercept is when y equals 0. Okay, these are also called the roots, the x-intercepts, or the zeros. The y-intercept, let me switch colors here, is when, oh, didn't write that very well, when x equals 0. So if you go ahead and put a 0 in here, you will get out the y-intercept, and that's about the only nice thing on this form. Then the vertex is when you put in x equals negative b over 2a, and that's explained under here actually. We'll find the vertex, okay, it'll find the axis of symmetry, and then you plug the x value that you just found back in to find the y value of the vertex, okay? And sometimes if it factors, you could factor to find the x-intercepts. All right, scrolling back up here for this particular equation. All right, so we have, the only thing that's nice to find is if we put in a 0 for all the x's, we'd have 2 times 0 squared minus 4 times 0 minus 6, which would just be negative 6, which is the y-intercept way down here, and it crosses the y-axis down at negative 6, okay? But that's not the vertex even. The x-intercepts, let's see. If I were to factor out a 2 here, I think I did that right. Take out a 2, 2, and 2. All right. Then I think this one does factor. X minus 3 and x plus 1. When we did this and this, we'd get an x squared in front. A positive 1 and a negative 3 added together would give us this negative 2. And this negative 3 times 1 would give us a negative 3 at the back. Okay, so this is factored form. If we set a 0 in here now, I hope no one is going to tell me 2 is a 0. Can 2 ever equal 0? Remember, the zero product property says this could equal 0, or this could equal 0, or this could equal 0. Well, 2 can't equal 0, so this is not one of the zeros. It's just a stretch. But here, if I put a 3 in here, then I would get this to be 0. And if I put a negative 1 in here, whoops, negative 1, then I would get this to be 0. So the zeros are at 3, 0, and negative 1, 0. 1, 2, 3, and negative 1. Now, my scale is not very good here. Let me try that again. If this is negative 6, then 3 would maybe be here, negative 1 would be here. Anyway, so there's what the general idea is. This was negative 1, and this was positive 3. This was negative 6. And the vertex still isn't on my picture, and probably will not look very good with my graph, because I should have found that first before I tried to draw it and connect all those dots. But all right, so we're going to use this vertex finder recipe. Again, A was 2, B was, oh my goodness, I just am not having luck with this slide. Negative 4, and C was negative 6. All right, so if I use x equals the opposite of B all over 2A. Now this 2 came from the formula, remember, right here. So the top becomes a positive 4, the bottom becomes about as a positive 4, and it reduces to 1. So x equals 1 is the axis of symmetry. Now to find the vertex, I put the 1 back in the original equation, which said y equals 2 times x squared minus 4 times x plus or minus 6 at the back here. All right, I put this 1 from right here into both of the x's here. So I end up with y equals 1 squared is 1 times 2 is 2, minus 4 and a minus 6 would be negative 8. And you could certainly type that in your calculator. So 1, negative 8 is the vertex. I'm feeling like I should be checking my answers as I go here, because we all know Hoffbauer could be doing these wrong because it's so easy when you're on camera to make a mistake, but who knows where I put my keys here. Yep, I don't know. All right, so right 1 and down 8 is actually, okay. I may need to start this whole video over. I'm a hot mess, huh? I'm just gonna keep going though. All right, so I had -1, +3, and -6, and then -8. All right, the axis of symmetry should be right down the middle, and it should be evenly spaced between the two x-intercepts, always. So if I go to the left 2, I'm at -1, right 2, I'm at +3, we're all good. This is the line x = 1. All right, so it took me 3 tries, but I think I got that one all graphed. Let me go to the bottom of this slide one more time and make sure we didn't miss any important information. I think we're good. All right, vertex form. This one is much nicer when you're graphing, okay? I have a slide that talks about the transformations a little bit more, but the opposite of this, so that would be H, tells you whether the graph slides left or right, and it is the opposite of what it says. So if it says x -3, it actually goes to the right 3, and if it says x +5, it actually goes left 5. All right, and K is the vertical shift up or down, and that one is not the opposite. If it's plus, you go up. If it's minus, you go down. And A out here is the vertical compression or stretch, and if it happens to be negative, then the graph is reflected over the x axis or upside down. All right, so back here we have the opposite of this. H is -5. We have back here K is 4. And up here we have A is -3. So if I scooch down here, see if I can keep that on the screen this time. My vertex is the easiest thing to find on this form, and that is just HK, so it's at -5, 4. The y-intercepts, are when I put in x = 0. So I would have y = -3 times 0 plus 5 squared plus 4. Now you can type this in your calculator, don't forget the parentheses, but it would actually be 5 squared is 25, then times -3 would be -75, plus 4 is -71, I believe. So the y-intercept is all the way down at -71. That is definitely not going to be on my graph. All right, the x-intercepts are when you set the whole thing equal to 0 or y equal to 0. So I'd have 0 equals -3, x plus 5, quantity squared plus 4. Now, I really just want an estimation for today. I'm going to go through the steps that we used last week. We don't want to mess with this, and we absolutely cannot distribute this. The only thing we could do that would make this nice would be to subtract a 4 over to this side, divide by -3, and then square root both sides, which remember gives us a plus or minus over here. Now the square root of 4 is 2. Unfortunately, there's a square root of 3 in the denominator down here, okay? And I have equals x plus 5. If I subtract the 5 over to the other side, Now, we could do some crazy business, like multiply this by square root of 3 over 3, and this would become -5 plus or minus 2 square roots of 3. This side is over 3, the 5 is not. If we wanted to make it over 3, we'd have to make it 15 over 3. Icky, icky, icky. I'm going to show you how to do these on the graph. Deal? All right, so what I want you to do is go to y equals on your calculator. First of all, if you're not in, go to mode and make sure these are all on the left. It isn't going to matter. I can make this one in radians, but it isn't going to matter for any of these. But you need to be in function mode down here. So full left is the default. So to put all those boxes on the left, that's for mode. Then go to y equals. Tell you right away, you're going to have a problem if any of these boxes are blackened in at the top. I went up arrow, hit enter, and back down arrow. These need to all be off, okay? If one of these is on up here, like this, you're going to have trouble graphing. So go up onto the box you want to turn off, and then scroll back down. Clear this out. All right, I'm going to type negative. I'm put it in just as it is. And this is my X button right here next to alpha. Okay, X plus 5. Close parenthesis, squared, plus 4. All right, I think for today we're okay with a standard window, which means just do zoom and 6. Standard window. Okay, so I can't tell where these two places that it's crossing the X is at. All right. It does look like -5, +4 is my vertex. Notice the scale is a little bit shorter this way and longer this way, but it does look like it's 4 up. Okay, but I want to estimate those two places here. Now, what I want you to get used to doing is literally estimating. 1, 2, 3, 4, 5. This is -5. Oh, I can't write on there. So this one is somewhere between -5 and like -2, somewhere in, ooh, let me put it on my screen. There's a good plan. Oh, shoot. Are you laughing at my video yet, guys? All right, so somewhere between here, -5 and like -2 is one of the zeros. And then this way, we'll just say like between -10 and -5 is the other one. Okay, somewhere in here is one of them, and the other one is somewhere over here. So then what you do is you use second trace, and you want to find a 0. So choose number 2 and hit enter. Second trace, 0, and hit enter. Then this is why I asked you to write those numbers down, because the first one on the left is somewhere between like -10 and -5. So it says left bound. I'm going to say look between, and I'm going to type -10, enter, -5, enter, and enter one more time, and it'll find it. Oh, now we get this glorious, this is, anybody know what that is? It's equivalent to -0.000000000011, which is basically 0. Okay, this is calculator error. All we care is to the nearest tenth or hundredth, so I'm going to go -6.15. Sorry. Is one of the zeros. And the other one is somewhere between -5 and -2. So I'm going to go back and do second trace, 0. And I want to pick the leftmost number I want it to fall between, which is -5. And then you could put -3, -2, -1, something to the right of there, and hit enter. For the guess, if you want to try to scroll to where it is, that's fine. I use these typing in of the numbers because I hate scrolling around, because as soon as I start scrolling around, a lot of times I lose that cursor. It goes off the bottom and then I don't know where it is, and it's a mess. All right, now that was very efficient of me. I lost my decimal, But I'm going to show you one more thing. I'm going to actually type this in to prove to you that we got the right answer that way. So I'm going to type -5 plus 2 square roots of 3, and just that little part is over 3, and it should jump. Oh, it was minus. What? All right. What did I type? All right, one more time. Trace. Trace. Oh, I won't let me type. There we go. I think I put an extra parenthesis in the front. We only wanted the 2 square roots of 3 divided by 3. All right, I'm kind of a mess right now. I should probably start this video over, but I hate these recordings, so I'm going to keep going. And my answer was -3.85 if I round. All right, so real quick, I'm going to go with this is -6.15. This is -3.85. This is -5. 4, +4, non-4. The axis of symmetry would go right through there, so that equation would be x equals -5. And the parabola would look like this. Okay, so for all my fumbling about, the vertex was easy to pick out of here, -5, +4. All right, and it wound up, because of this negative, it meant it opened down or was reflected over the x-axis. And the 3 actually made it narrow. It doesn't look very narrow here because of my scale, but if you look over here, you can tell it was pretty narrow. Just to show you, if I got rid of the 3, just to compare it, there it is without the 3. So then when I had a 3 there, it was narrower. All right. I'll do another one of these in a minute, so hang on. One more time, this slide is for reference. It does talk about the A. If it's negative, it indicates a reflection over the x-axis. And a vertical stretch or shrink. Let me scroll down and talk a little bit more about that. Okay. If A is greater than 0, if this should be 1. This is not a good slide. Okay. If A is greater than 1, then it is a vertical stretch. It's going up faster than normal, so it's going to get skinnier. Okay, you got to think about what it's doing. It's vertically stretching it. If A is between 0 and 1, okay, that would mean a fraction, like a 1/2. Okay. That will make it go up half as fast, so it will be wider. So it will be wider, okay? All right, great. Could I make this video any worse? All right, we're gonna try another form here. No, this is the last one, okay. So factored form is really nice for finding the zeros and not much else, to be honest. So the x-intercepts, or zeros, are what you get when you make y 0. Well, 1/2 does not equal 0. That's not true, it doesn't work. But x minus 5 could equal 0 if x happened to be 5. X plus 3 could equal 0 if x were -3. So I would get a 0 if I put in a positive 5 or a negative 3. Now, the y-intercept, again, is just found by putting a 0 into the original equation for x. You could do this on your calculator, but it's going to be 1/2 of negative 5 times 3. 5 times 3 is 15. Half of that is 7.5, and it's negative. So the y-intercept, when we plugged in a 0, we got negative 7.5. Which I must say is down here somewhere. All right, but we need the vertex before we try to draw that. I already tried that once today and it didn't go well. Now, I don't know if you remember this hint. There's several things we could do, but the easiest way in this form is that the axis of symmetry is exactly between the x-intercepts. So it is the average of those two numbers. So negative 3 plus 5 divided by 2 would give me 2 divided by 2 is 1. So x equals 1 is the axis of symmetry. So we averaged and we got x equals 1. That actually means that the vertex goes through the coordinate 1 something. Well, to find the something, let's just put 1 back in here again. 1/2 of 1 minus 5 times 1 plus 3, which is 1/2 of negative 4 times positive 4. 4 times 4 is 16. Half of that is 8, and it's negative. So we get a negative 8. Could use your calculator. What you can't do is take half of this 4 and half of this 4. Remember, you're multiplying. You only multiply that half once. All right, so down here, just below this, at 1, negative 8, is the vertex. So here's my graph. Whoa. Trying to make it rounded. It's not a V. All right. So real quick, before I go on, let's talk about one more word here. The word I want to talk about in terms of the vertex is the words are maximum and minimum. If this graph stops going down and starts going back up, it has a minimum point right here. All right, it's like the bottom of the bowl, okay? That's the lowest this graph will ever go. It'll keep going up forever, but this vertex is a minimum. On this graph, because it opens down, it will go down forever, but this point right here, the value, y value of 4, is the highest this y values will ever go. That is a maximum point. The vertex on this one is a maximum. And on this one, because it was opening up, this vertex was a minimum again, because that is the lowest this graph will ever go. All right. This again talks about the A value. Remember the A value out in front? No matter what the rest of this looks like, this A value shows whether the parabola will open up or down. When the A value is positive, it opens up, negative, it opens down. But the words we use for that are really, it is reflected over the x-axis. All right, and the A value also indicates the vertical stretch, whether it's narrowed, it's going up faster, and that would be when A is greater than 1. The absolute value of A we're supposed to write here because you'd ignore the negative, okay? and it is compressed, which actually makes it wider when the A value is somewhere in between 0 and 1, like 1/2 or 2/3, etc. Now it can be negative, but the negative just indicates that it's going down. All right, the opening direction also tells us whether, if it opens up, we have a what? A min, and if it opens down, we have a max. So we want to put in this blank indicates whether the vertex is a max or a min, maximum or minimum point. Okay. All right, so that's basically the lesson. We're just going to do some examples where we change forms and do a little more graphing. Wow, I'm at 30 minutes already. All right, I'm going to go quick. So this is to change the forms. If you wanted x-intercept form, all you'd have to do is factor this. Let's see, x minus 5, x minus 1. If you flow that back together, you get this. And remember, x-intercept form is basically factored form. So that was a quickie. All right, this one wants us to change this to vertex form. The way you can do this when A is 1 easily is to complete the square. I'm going to review that for you. You subtract all the constants over here, so you get y minus 1, and you put a blank. And you leave anything with an x over here, and you put a blank. And then the rule is, whoops, that's arrows in the wrong spot. You take half of this b value and put it down here, so I get x minus 2. And then I put a squared, because x minus 2 times x minus 2 would have had to be x minus 4, x squared minus 4x, and then you square that b term back up here, the b over 2 gets squared, and it becomes a positive 4. Whatever I put in that right-hand blank, I have to put in the left-hand blank, and then I end up with a plus 3 over here. And if I want it in vertex form, I'm going to subtract that 3 back to the end and end up with x minus 2 quantity squared minus 3. Now, the other way we could have done this one is the way I'm going to actually do this one, which is to use that vertex finder recipe. X equals negative b over 2a. If I use that on part C here, I will have the opposite of negative 12 over 2 times 2, which will become 12 over 4, or 3. So the vertex has an x value of 3. If I plug that 3 back in, I get 2 times 3 squared minus 12 times 3 plus 7. This becomes, you can type it in your calculator, but this is 9 times 2 is 18 minus 36 plus 7. I believe that's negative 11. So here's the trick, guys. Now that you know the vertex, you know h, you know k, and this guy was a all along. So to put this in vertex form, you have y equals a, x minus h, squared plus k, or minus 11. And so we didn't have to complete the square. That's my shortcut. Because when you have a 2 out front, it's a hot mess completing the square. All right, moving on. I'm going to do real quick number 3, 4, and 5. No, I'm not. I'm going to do 3, 5, and 7. Quickly graphing these. All right, this one is not in a nice form, so you have a couple options. You could graph it on your calculator and try to find some nice ordered pairs. I would highly suggest that the first thing you need to do is find the vertex. So I'm using vertex finder here. So I got that the vertex is at negative 3, so the axis of symmetry is over here at negative 3. And when I plug that negative 3 back in, being really careful using your calculator. Okay, -3 squared is 9. This makes the opposite. This is a negative times a negative. Okay, I'm not using a calculator, but I'm going to get 1 here. So I got -3 and 1. -3 and +1 is the vertex. Now, I know something about this parabola. I know it opens down, okay? And I know that it has no stretch. So normally when I put a 1 in, I got out a 1. If I put a 2 in, I got out a 4 when I squared it. So that's actually what's happening from that vertex. If you go out 2, whoops, I did it wrong, didn't I? I can't count. It should go down 4. There we go. And it's symmetric, so it should do the same thing on the other side. The other thing I know right away is that the y-intercept is when I put a 0 in. Well, if I put a 0 in, all that's going to disappear, and it's just going to say -8. When x equals 0, y is -8. So it crosses down here, which means it's symmetric there as well. Okay, I didn't even hit half the dots. All right, the x-intercepts I also could have gotten by factoring. And it factors x plus 2, x plus 4. So the zeros were at -2 and -4. All right, that's where those are. I'm going to pause the video. All right, guys. Number 5, vertex form. So h is -4, k is -6. So the vertex is at -4, -6. The axis of symmetry is through x equals -4. And it opens which way, guys? Okay, so this means it's been shifted left 4, down 6, right down there's the vertex. The 1/2 actually means it's going up half as fast. So normally when I square 1, I go over 1. So I go 1, 1. And then 2 squared is 4. But I'm going up half as fast. So I'm thinking it's going to do this. And instead of going over 2 and up 4, because you squared it, it's only going to go up half as much. Okay? But we could find the x-intercepts. I don't think they're going to be nice. We would have 0 equals 1/2 x plus 4 squared minus 6. You could definitely do this on your calculator. But I'm going to do it algebraically. I'm going to add 6 over to this side. Now be careful. You're dividing by 1/2. Dividing by 1/2 is actually multiplying by 2 onto both sides to get rid of that 1/2. So I end up with a 12 over here. And then I would need to take the square root. And I'd end up with plus or minus the square root of 12 equals x plus 4. Subtract a 4. Square root of 12 is actually 4 times 3, so I'd end up with 2 square roots of 3 if I simplified that. Those are the two x-intercepts. Nothing pretty, but if I were to either graph the original or type those in, I'm going to show you the original one more time. I'm going to use 0.5 because I'm in a hurry. X plus 4 quantity squared minus 6. This is what the graph looks like. Okay, we want these zeros. There's one over here somewhere between, I'd say, -10 and -5. So 0. Second trace 0 between, it asks left bound is -10, enter. I'm going to say the right bound is the vertex, which is -4, enter. So somewhere in between there at -7.46. is an x-intercept. And the other one would be symmetric. You could find it the same way, or again, let's check my algebra. If we do -4 plus 2 square roots of 3, let's see if I did it right, jumps right to that one where it's 0, and that is at -0.54. All right, you don't have to be as picky about how you get them. I don't care which way you get them, but try to find those x-intercepts. Good practice for all the homework and the quizzes, okay? One more. This one is in x-intercept form. So the x-intercepts are at 7 and 3 because it's in factored form. So we have 7 and 3. The vertex is exactly halfway in between those. The axis of symmetry is at the average of those, which will be 10 divided by 2, or 5. So x equals 5 is the axis of symmetry, which means the vertex is on that line somewhere at 5 comma something. So if I put a 5 back in here, I get the opposite of -2 times +2 would be 4. So the vertex is over 5 and up 4. All right, so just reviewing, that means this one has a maximum at that vertex, okay? The only thing we didn't find for this one is the y-intercept, is when you put in a 0, which would be the opposite of -7 times -3, which would be -21. So if I put in a 0, the y-intercept is clear down at -21. All right, that's this lesson. I'm going to go back and do the evens on the notes, but now do your homework, please.